Okay, this lecture is a continuation of percentage composition. We're now, just like in mathematics, if you go from multiplication to division or addition to subtraction, we do the same thing here. We're going from percent composition to see what percent a certain element is of a compound. Now we're going to be given that information to determine what the compound is. All right? So let's look at this a little bit. The first thing we have to look at is some terminology. An empirical formula is the simplest ratio of elements in a compound. An example would be if I had benzene, which is C6H6. You notice that both these numbers are divisible by 6? So the empirical formula would be CH. Yes or no? Okay? So far, so good. Well, scientists kind of need to know, and we need to know when we make new compounds in our experiments, we need to know how much really reacted, and we can figure out percentages. So that's what we're going to be looking at today. I have an example here. Excuse me, right over here. The example is this. I have a substance that has potassium in it, and it was 40.2% potassium. It is 26.9% chromium. And it is 32.9% oxygen. All right, let's think back when we did percent composition. All right, we were using grams. So what we're going to do something magical. Okay, everybody think magic. All right, and we're going to just like poof and change this to grams. And I'm going to show you how to do that. Watch.
Wow, that was magical.
That was magical. Well, this one too, watch.
Holy.
And last but not least is...
Who would have thought?
Who would have thought? What did I do? What is the only thing I did?
Just
I went from percent to grams. Now, the theory is this. I need to pretend that I have 100 grams of substance. I have 100 grams of substance in front of me. Okay? And if I have 100 grams of substance sitting in front of me, if I have 40.2%, how many grams do I have? 40.2? Yes? So that's what I'm going to use. I'm going to use this premise. Now, we know that in compounds like this one, it says I have 6 moles of carbon to 6 moles of hydrogen. Moles. Not the little brown furry things, but the quantity in chemistry known as a mole. All right, if I have 40.2 grams of a substance, can I determine how many moles I have? Think, how many moles would I have? How do I determine it? What do I need to use? Do I have to use factor conversions? Do I have to use dimensional analysis? Oh no, not dimensional analysis. Yes. Yes, it is dimensional analysis. All right, so we're here. 40.2 grams of potassium. I'm going to locate there. How do I change 40.2 grams potassium into moles? Casey, I'm waiting. Do I want particles? I want moles. Okay, here. If I have grams potassium in the numerator, what must I have in the denominator? Grams of potassium. The grams, they have to match, okay? Where can I find grams of potassium? Very good, I heard it, on the periodic table. Can someone research that for me, please? Because I'm hard of hearing, I probably won't hear you anyway. I'm using our periodic table. So again, if you are not using our periodic table, it might be a little bit different. And I have this, using dimensional analysis, is 1 mole of potassium. True or false? Is it all coming back over the weekend? Okay. Okay, now using that as an example, what am I going to do here? Remember, this is chromium. What am I going to do here? Using this as an example, what do I do here?
1 mole on top.
1 mole of chromium on top.
Whatever.
Can you remember 51.996? Okay? I know it's a little scrunchy. I should have maybe spaced them out a little bit more. Okay, this is oxygen. What do I have here?
15.9994.
Now I have them set up as moles. Now remember, just like this one, 6 moles of carbon, 6 moles of oxygen, or hydrogen, correct? If I had CO2, I'd have 1 mole of carbon to 2 moles of oxygen. If I had water, I'd have 2 moles of hydrogen to 1 mole of water. Come on, people, work with me, water. Oxygen, okay? So using our handy dandy calculators or phone calculators or whatever you have handy, 40.2 divided by 39.0983. I'm going to round these a little bit for the sake of time. Okay, I get that. See how easy that was? We do not see how easy that was. Okay? All right? So all I did is I took each grams divided by the number of grams to make a mole, so these are all moles now. Now, when you did the bean lab, you did a comparison, did you not, to the same bean? We're going to do that here also. Which one is the smallest number of moles? Which one? Which one is the smallest number? Chromium at 0.517. So I'm going to divide each one of these by 0.517, and I'm going to get a ratio. So this is going to be what? Well, this is going to be what? 1. Very good. This is going to be what? I have a feeling that maybe we need to remember to bring our techo devices here.
I'll do it myself. I got it right down first.
Oh, really?
Yeah.
Whoops. Okay, this number that I got was like 1.9997 something, whatever. So that's really an approximation of 2. This one was 3.9967 whatever, which is a close approximation to 4. So now I have some nice whole numbers to work with, thank goodness. All right, that means that in this case I have 2 potassiums, 1 chromium, and 4 oxygens. 2 potassiums, 1 chromium, and 4 oxygens. Potassium chromate. Yes? That's a compound I have.
Hold on. So you just divided that by the smallest one?
I tried by the smallest one, and I got this. Is there a pause on that? Okay. Let's try one more. You with me?
Yep.
Okay. Does everyone get this down that wants to write it down?
Mm-hmm.
Great. As you can see, this is one of the reasons I wanted to separate the percentage composition, because once you feel comfortable doing that, then we can move on to this. It was good. So strontium at 65.7%, silicon at 10.4. I'm going to give myself a little bit more room than I did last time. And oxygen at 23.9%. Okay, what's the first thing you have to do? Convert them to grams. Oops, maybe I need a G here so I can separate because that looks like a 0, doesn't it? There we go.
Mhm.
Got it? Now what do we do?
Put them in the dimensional.
U for dimensional analysis. And what's the numerator on each one of these going to be?
1.
1 mole. Good job. Okay. I know this one by heart already. 15.999 grams. I don't know strontiums, but I don't know sulfates. Okay, if I get them written up, can somebody take the initiative and start figuring these out?
Bottom one's 1.49380601.
Is that close enough? Okay.
Alright,
All right, next one.
This one is 0.3703.
Okay, thank you. Anyone do strontium yet? How much?
0.74982288.06.
Okay. I'm not going to be so concerned about significant digit. Well, she'll be 4 anyway. But anyway, as we continue on, which of these numbers is the smallest one?
The middle one.
The middle one. It's a 0 point.
Oh, okay, sorry.
Okay, that's okay. Maybe I'll put a 0 there. Okay. This is the smallest one, so I'm going to divide everything by 0.3703. This one's 1. I didn't even need a calculator for that one.
Four on the bottom.
4 on the bottom.
Two on the top.
And 2 on the top. Now, it worked out the same again, and I don't know why. It shouldn't have. I mean, I did do that on purpose. So my formula would be SR subscript 2 SI, I don't need a subscript there, O4. Strontium silicate. Yes?
Mhm.
This good?
Mhm.
Are there any questions?
Mm-mm.
Okay, we'll upload it, and you will be able to view it if you